Okay, good morning, guys. Can you hear me? Can you see me? Just want to make sure. Just type in the chat if you can hear me and see me. Okay, good. Sorry for the delay. Ooh, it's not showing. Not showing. Give me a second. It should be showing day two. Still showing day one. My bad. Hold on. Let me fix that. Okay. So now it's showing. I didn't know why it wasn't showing. Okay, so let's start with the land acknowledgements. We acknowledge we're hosting the lands of the Mississauga of the Anishinaabe, the Haudenosaunee Confederacy, and the Wendat. We also recognize the enduring presence of all First Nation, Métis, and Inuit people. Okay, let's get down to business of today. Today is August 1st, day two. Okay. I hope everyone did the quiz yesterday for what we did yesterday. Okay, you get two attempts. The higher score is what is being recorded for your mark. Okay. I want to emphasize the worksheets that I give you guys to do does not count for marks. So what does that mean? You don't have to submit it. Okay. I put it there because I want you guys to practice, obviously. This is no textbook. Uh, and you can submit it if and this way you have things to work on, but it doesn't count for mark. What counts for marks is the quizzes I give you every day. Okay. So remember that. And then on next week, when you guys do your first unit test, that will also count. Okay. So don't stress yourself out. You don't have to do every single question, right? I know there's lots of questions for the worksheets. Maybe do a couple for each bit of it so you have an understanding. Okay. But don't stress yourself out thinking you gotta do every single question so I can submit it. You don't. Okay, so I'm saying it in Zoom. There's a reason why I should come onto the Zoom. That way you get information versus panicking and sending me emails afterwards. The test will not be multiple choice. The test will be handwritten. The test will be sort of like the worksheets. You have to handwrite everything, and you have to submit one file. Okay, so let's get on to what we're doing today. When the test comes, we'll talk about it. So today we're talking about inverse function, simplifying polynomials. Okay. Let us get into, and I put a hot links here for the worksheet and for the quiz, but you can also go into actual space, the content to get the worksheet, or go into quizzes to get the worksheet, to get the quiz. Okay. You can even go into assignment to get the worksheets, but the best way is probably just go into content or into or click on here. So let me make sure I see what you guys see. So I'm going to come in as a student. So give me a second. I'm going to view Brightspace as a student. That way I want to know what you guys see. That way you guys don't say, oh, sorry, I don't see it. But I do see it if I'm viewed as a student. Okay, so announcement shows, that's fine. Go into content. What's showing for today? What's showing for today is um, August 1st. Okay, we're doing the lesson for August 1st. And then we're doing the inverse. Okay. Um, And we're doing simplifying functions. Okay, so, okay, give me a sec, okay? Give me a sec. I gotta handle this cat that's getting in my way. Okay, sorry about that. I was dealing with a cat that was trying to get into my screen. Okay, let me just double check the quizzes for today. Yes, you have quiz number 2. You're able to see it, right? And it's due today at 11:59 p.m. Okay, August 1st today. So please work on that after you've done the worksheets. You understand you get 2 attempts. Okay, going back, let's get into it. So we're looking at lesson 3 for August 1st. Inverse function. We're gonna look at the video first. Let's start with that. Okay. So what I do is I'll play the video lesson, then I'll pause in between, and then I'll emphasize things, and we'll continue. Okay. So here we go.
Last lesson for the transformations unit. It's the last kind of type of transformations.
Okay. Did you guys hear it? I want to know if you guys can hear it. Let me know in the chat. Okay. And if it's not loud enough, you maybe got to turn up the volume on your computer. Okay. So here we go. Inverse function.
We've looked at horizontal stretching, compressing, vertical stretching, compressing, shifting light left, right, up, down. We've also looked at something called a vertical and horizontal reflection. The inverse of a function is actually kind of like a diagonal reflection. It's going to be reflecting across the line y equals x instead of across the x or y axis. Like a vertical or horizontal reflection, we're going to be reflecting across the line y equals x.
Okay. So just for you guys to understand, inverse of a function, because he didn't really, some of you guys, no, you don't ask in the class because there's no time for me to go through it. You gotta ask in the email, okay? Because I gotta do an hour of the lesson. Thank you. Okay, so inverse of a function, I'm just gonna draw on the screen, x and y axis, okay? So normally you write something like this, right? Say y is equal to, I don't know, x squared, okay? The inverse of a function means we swap. I'm just doing a quick summary because he's going to go through the detail. We swap between x and y. Okay, first of all, inverse of, when we write like this, y is equal to x squared. Remember from yesterday, we talked about uh, function notation. So that's the same thing as saying this, right? Remember that? Those two mean the same thing. Okay? Okay, let me erase this. Looks a little bit unclear. Do that again. It means the same thing as this. Okay? So when we say inverse of a function, what we're trying to say is we want to write inverse of f of x. That's what we're saying. But in order to get that, there's steps we got to do. Okay? And he's going to talk about the steps. Right? What we're trying to do, this does not mean to the power of -1. Okay? That does not mean that. It just means inverse. Okay? And what you're doing basically is swapping the positions of x and y. So if I were to write this in an inverse, I would write it like this. I would start off like this. Y is equal to x squared. Then I would swap and I'll put the x over at this side and I'll put the y over on that side. Okay? That's how I would start. And then the idea is to get y by itself. Well, to get y by itself, that means I bring this square root sign and bring it over to there, and that becomes square root sign, that becomes square root x. Okay. Equal to y. Okay. And then as a result, basically I would then turn that into okay. That's the summary. Okay. So we're gonna go through it. I just want to just get you an idea. So you start off y is equal to x squared, and then you want to get the inverse, and you want to get this notation, right? So as a result, you swap x and y, and then you isolate the y, and then you get something like this. Okay. So that's what we're gonna go through. So hold on and listen to the video.
So inverse of a function, we have a notation to indicate that we're finding or have the inverse of a function. And the notation is this f with this thing. It looks like an exponent of -1, but it's actually just notation. It's not an exponent. To get the inverse of a function, to reflect it diagonally across y equals x, all we have to do is essentially switch the x and y coordinates with each other. So if
Okay, so that's what I just said, right? He's saying the same thing. So here, that's again the inverse notation. And so if I have here, if this is the regular function right here, f of a is equal to b, then the inverse would be inverse function of b is equal to a. That's all we're doing. Okay, so if f of 5 equal to 13, then inverse of f of 13 equals to 5. Okay, so that's what we're doing. So let's kind of fast forward. So that's what he's doing. So here would be the coordinates of the first function, the regular function, 5, comma 13, but the inverse would be 13, comma 5. Okay. So to draw, you basically to draw an inverse, you swap the x and y coordinates. Okay. So here is an example. Here's the function, right? Here is the function right here. And then he's going to write the inverse. So one thing you can do is from this function, figure out what is the actual x and y, and then swap x and y, and that's your inverse function. Okay. Now with this question here, this is a transformation. If you look at this, this is a transformation, right? Some sort of transformation, okay, of the x squared function, which would be the parent function. So let's play this example. Back up a little bit.
reflected diagonally across the line y equals x. So let's actually do a question where we find the inverse of the function g at x. So g at x is equal to this transformed version of, it looks like our parent function is root x. So I'm going to, since this square root here, that tells us that our parent function, I'm going to call the parent function f at x. The parent function is root x. We'll have to remember what.
Okay, so that's the parent function of this, right? So right now, what he's going to do, he's just going to write down the parent coordinates of this, and then he's going to write the transformation of that, okay?
That looks like. We'll have to apply the transformations to that parent function using our a, k, and c values to get the points for our transformed function g at x. And then we don't want to graph g at x, or we do want to graph g at x, but our end goal is not only to graph g at x, but we also want to graph this, the inverse of g at x. And remember, this exponent, or it's not an exponent, it's a notation. This -1 is not an exponent. It's just a notation telling us it's the inverse of g at x, which means we just take all our x and y coordinates from g at x, and we switch them all with each other, and we will get the coordinates for the inverse of g at x. And I think on this page over here, I forgot to scroll down, but I actually made a note here. And important to note, Inverse of f of x, this -1 here, it's read as the inverse of f of x, not f to the exponent of -1.
Okay, so we already said that, right? So f of to the -1 is not a negative exponent. It's just, so it does not mean this, because someone's going to say, well, it just means the inverse of, so I'll just do 1 over. No, that's not, it doesn't mean that. It's just does not mean that. It's just a way to write as an inverse. Okay, that's what it says. Does not mean this. So remember that. If you do that, that means you didn't listen, you didn't follow the instructions. Okay.
This -1 does not behave like an exponent. This does not mean 1 over f of x. It doesn't act like an exponent. It just means the inverse of f of x. Let's get back to this example. So first, keep.
Okay, so right now he's going to give you the coordinates for the parent function, right? So the parent function, so if x is 0, what is y? If x is 1, what is y? If x is 2, what is y? Okay, that's what he's going to do for this.
Key points to the parent function root x. Hopefully you remember, I chose perfect square x values so that we can get integer values for y. Square root each of.
Okay, so the reason why I chose 0, 1, 4, and 9, because if I put the square root of 0 is 0. If I put the square root of 1, it's still 1. If I put the square root of 4, I get 2. So you put numbers that'll get the perfect square, okay? If I put a 9 for x, I'm going to get 3. That's why I did that, okay? So as a result, this is what you get, okay? So now we are going to figure out, because this is not what we want. We want to know what this is. This g of x is a transformation of this. So you have to remember your transformation, right? So the 2 will stretch the y, but and then this half here that's on the x will actually stretch the x by a factor of 1 over k. 1 over k is actually, this is k. So k, 1 over k, that means this would be 2. And then this 3 will move it up and down on the y-axis by 3. Okay? So that's what he's going to have to put up there so you guys can see. I want to play the video so you can hear it.
Okay, well, let's start with the horizontal transformations. K is -1/2. So first of all, that's going to be a horizontal reflection because it's negative. So the x's are going to have to be multiplied by a negative value to change the sign of them. And the k value, we always have to flip it. So we have to do 1 over 1/2, which gives us 2. So it's going to be a horizontal stretch by a factor of 2. So we'd have to multiply.
Okay, so like I said, horizontal stretch by a factor of 2. Okay, for the x-axis. So every x value I'm going to multiply by 2. That's what that means.
Multiply the x's by 2. Combine those two things, multiply the x's by -2.
So now I got my x. What I'm going to do to my x, my transformation from x. There's nothing else that applies to the x here, so now I'm going to figure out what my y is. My y, I'm going to multiply each y value by -2, so it's going to stretch. But it's also, there's a negative there, so it's going to flip it. So, but still a -2, I'm going to multiply each y value. And then my x, sorry, my y, I'm also going to add 3. So I'm going to multiply by 2 every y, I'm going to add 3 to it. So that's what he's going to do there. There you go. Every y value multiplied by 2, and I add 3. Okay, so that's what I'm going to do for each of these. So if I plug in 0 here, 0 times -2 is still 0. 1 times -2 is -2. 4 times -2 is -8, and so on. So I'm going to get my x components. I'm just going to fast forward a little bit. There you go. And then -2 times 9 is -18. There you go. And now for the y's, I'm going to multiply each y by -2, and then I'm going to add 3. And that's how I get this column here. Okay. There you go, right? So -2 times 0 plus 3 is going to be 3. Okay, and so on. So then we fill up this column. Okay. There you go. Now, to get the inverse, all we're doing is swapping x and y. So over here, my x was 0, my y is 3. That means here, in the inverse, my x is going to be 3, my y is going to be 0. Okay, so watch.
There's the points for the function g at x. Let's start by, actually, let's graph g at x. So plot the point. Oh, and notice I made my scale go by 2's so that I could actually fit these points onto the graph. So the point 0, 3 would be right here. The point -2, 1 would be right here. The point -8, -1, -8, -1 would be right here. And the point -18, -3, 10, 12, 14, 16, 18, -3 would be right here. So remember the parent function root x, just roughly, it looks, well, not.
Okay, so he's just showing you what the parent function looks like. Okay, then he's going to show you the transformation, I believe, and then the inverse. Okay.
Not quite like that, more like this. That's what root x looks like, like curved looking. It only exists to the right, of the line, x equals 0, right? Because we can't square root a negative number. But keep in mind our transform function, it's been horizontally and vertically reflected. So instead of continuing up to the right, it's going to be flipped vertically and horizontally. So it's only going to be continuing, oops, and I should do this in blue, down to the left. I didn't connect those very well, but you can imagine me going through those points with a smooth curve. I'll try and do it a bit better. Continuing in the downward to the left direction. So that's what our function g at x looks like. If we want the function...
Okay, so now that's the function of g of x. Now the inverse is basically swapping the x and y points, coordinates, okay? So it's going to look something like, if I were to draw, it's going to look, if I swap it, it's going to look something like, if I'm drawing on a screen, it's going to look something like this, okay? And that's not exact, but he's going to show you based on plotting it on the graph there.
Inverse g at x, what we have to do is we have to take all of these points and just swap the x's and the y's with each other. So instead of 0, 3, we'll use the point 3, 0. So 3, 0, 1, -2, -1, -8, -3, -18. So I just kept all these same points, just swapped the x's and the y's with each other. So if I plot those points.
Okay, so he does like I said before, you plot it, there you go. It's gonna look something like that. That was actually better than the way I drew it. So that's what it's gonna look like. That's the inverse of this, okay? So, and here's like the inverse line. Okay, so this line here represents the inverse. But again, what you want to do is basically plot switching the x and y components. Okay, so let us go to the next example. You can watch the video on your own if you want more understanding, but I'm just going to tell you things that's important. So that's what you just plotted, right? The inverse. Okay.
Hey, good morning,
So,
sir.
hey, how's it going?
Good. How are you?
Good. We got a surprise guest here. We have our program administrator, the VP. He's coming in to say hi to you guys.
Hey, good morning, everybody. Thanks, sir, for the introduction. My name is Mr. Alvey, and I'm the program administrator for grade 11 math this summer. In the chat, I've put my contact information. If you have any questions or you just want to know, ask anything, you can email me and I'll get back to you right away. Other than that, I wanted to wish you well in the course. Stay on top of it. It's a really fast-moving course, lots of information in a short amount of time. So good luck, Best wishes to everybody, and I know you're going to do really well. Thank you. Thanks,
Okay,
sir.
thanks. Bye. Okay, guys. So this is basically showing you. So remember, it's in the chat there. Copy that. I would copy that, guys, and put that in your in a safe space so you can get information or contact the program administrator if there's any issues, okay, that I can't help you with. So make sure you copy that. Okay, it's important to copy that. Okay, but moving into what I was talking about was inverse, and that's here showing you the summary. Okay, so how to get the inverse. So f of x, right? Replace that with the y, and then you switch your x and y variables, and then isolate your y, and then after you isolate your y, you replace y with f of the -1 x, and that just means inverse. Okay, so let's continue. Now here's one example. Okay, now you have here g of x equals to 3x over 4. So let's go through this example.
We'll replace g at x with y. So y equals 3 at x over 4. Inverse functions, the x's and the y coordinates switch with each other, so we'll do that in the equation. Instead of writing y, we'll write x. Instead of writing x, we'll write y. And now we just rearrange this equation algebraically to isolate y. So multiply the 4 over, and then divide the 3. And then lastly, we'll write the proper notation. Instead of writing y, we will write the inverse of g at x, right? We no longer have g at x, we have now the inverse of g at x. It's equal to 4x over 3.
Okay, so you can see how we do that one, right? So that's pretty easy. All right, let's look at the next example. I think this should be easy too, right? So you're going to replace, so you have h of x equals to 4x plus 3. So you're going to replace h of x with y, and then you're going to have y is equal to 4x plus 3, and then you basically swap, right? So wherever x is, you're going to put y, and wherever y is, you're going to put x. So x is going to go over here, and it's going to equal to 4y plus 3. Right? And then you isolate your y. Okay, isolate your y. And as you isolate your y, then your answer when y is isolated, right? There you go. Fast forward a little bit. And then now you're going to change that y into f of x with a -1 as to show inverse. Okay. And back up.
All over 4.
Well, you go back to h of -1x, right? So that's basically what you're putting, and you go back to that. Okay. Let's look at another example. Let's see if there are any more examples that are complicated. Okay, this one is a little bit more complicated because you have a square there. So let's look at this one.
I don't know if we need to I don't think we need to do that example. That's similar to what we already did. But c, so f at x, let's write the equation for inverse of f at x. First by changing it to y. Then by swapping the x and y with each other. So x equals y squared minus 1. Move the so now we want to isolate y. So x plus 1 equals y squared. And then to move the squared over, we have to square root, but then don't forget we have to consider both possible answers for the square root of x plus 1, the positive and the negative.
Yeah, you got to put the positive and the negative, right? Because it's just like if I were to write, and the reason why, someone's going to say why. Well, if I square this, I still get 9, right? If I square this, I still get 9, right? That means, right? That means if I were to go the other way around, that, and I'm going to put over here, that means square root of 9 equals to -3, right? Or square root of 9 is equal to 3, right? That means, I write again, that means I'm going to write over here, shoot. from coming off the screen. That means square root of 9 is equal to plus or minus 3. Okay? That's the reason why you got to do that, because it could be plus or minus, right? So that's why you have here plus or minus. Okay? So let's continue. Let me just clear that up.
Or else we would only get half of the graph for the inverse of the function. And now that y is isolated, we can go ahead and replace that with the symbol for inverse of f of x equals plus or minus the square root x plus 1. Let's do last example for this one. When we have a quadratic written in standard form, to be able to write the equation of the inverse, first thing you're going to have to do is convert it to vertex form.
Okay, so vertex form is something you're going to have to be able to do. Okay, so that will involve completing the square, so he's going to go through that quickly.
We'll first change f of x to y. So y equals 2x squared plus 16x plus 29. Notice that there's two x's in the equation and one of them is squared, so we can't collect. So what we're going to have to do is we're going to transfer this to vertex form by completing the square. So hopefully you remember how to complete the square.
So completing the square, that was in grade 10, right? So when you converted the standard form to vertex form, that was a grade 10. So basically look at the first two terms, okay, and then you put a bracket around the first two terms like what he's doing, and then you're going to see if you can isolate, you can factor out a number. So that's what he's going to do there. And fast forward a little bit, right? So bracket around the first two terms, he's going to factor out the 2 because the x should be by itself. So when he does that, then it's going to have here bracket x squared plus 8x. Okay. And then you look at the second term, the 8x, and what you do is divide that by 2 and square it. So if I divide 4, the coefficient, if I divide 8 by 2, that's going to be 4, and then I square 4, that means it's going to be 16. Then I have to minus 16. I have to add 16, yes, for my answer. But I have to also subtract 16. What I'm doing is a fancy way of just adding 0. Because I'm not changing the value of the equation, right? So if I add 16 to an equation, I must subtract 16. So that's what's going on here. Watch. Okay? That's a fancy way of adding 0. But now what I can do is I can take this minus 16 outside. And when I take it outside, I have to also multiply by that 2 there. Okay, so I take it outside. So minus 16 comes outside the bracket, but I got to multiply by 2. That becomes minus 32 out here. And then inside the bracket, I'm left with, okay, minus 32 plus 29. So now I can, this here, x squared plus 8x plus 16, that's a perfect square, right? So two numbers that give me 16, when I multiply them, two numbers when I add them together give me 8, it's going to be 4. So I'm going to have here 2 on the outside, bracket x plus 4 squared. That's going to be my answer. And so I'm already getting close to bracket notation. Minus 32 plus 9 gives me minus 3. So here's my vertex notation now. Okay.
Negative 32 plus 29 is negative 3. Here's our quadratic. It's now in vertex form. So now what we can do is swap the x's and y's with each other.
Okay, so now I can swap x and y and then come up with my inverse. So that's what he's going to do. So again, you swap x and y wherever x was, put it as y. So he's going to do that, right? And again, from there, you guys should know how to do this now, right? This should be simple, right? Bring the 2 over to that side, that's multiplied by the 2x. Then I'm going to add the 3. I do that, right? Sorry, divide by the 2. Okay. Now that square, it's going to go over to that side and square root into this. plus or minus, always have to have that. Okay. And then you have y plus 4. And then you have to bring the 4 over to the other side. It's going to be minus 4. Okay. And then
y is now by itself, so I can write the inverse notation, inverse of f of x. So that was just gone through really quickly, how we can algebraically write the algebraic.
Okay, so that's basically doing inverse notation. I might have spent a little bit too much time on that because now I got to do simplifying polynomials, and there's different ways to simplify polynomials. Let's go to, let's see if I have a video. Yes, I do. I'm going to go into the video. There's a few videos here to simplify polynomials, okay? So we don't have much time, so I'm going to go through adding and subtracting polynomials. This shouldn't be difficult when we talk about simplifying polynomials. There's different ways. You can add, subtract polynomials. You can multiply polynomials. That's maybe multiplying two binomials, like the FOIL method. You can do common factoring, okay? You can do factoring simple trinomials. Okay, you can do the perfect square like we talked about. Then we talk about difference of squares. So all of these are different ways you can factor a polynomial. So let's look at, I'll look at a couple of examples for each of them because we don't have time. So let's start off with adding, subtracting. This is probably the easiest one. We'll fast forward through some stuff.
Tell me you're a runner. You're pushing on and powering through. Tell me every second counts. Whatever you have to tell the world, say it with sport.
How do I clean an aioli stain?
Okay, just gonna pause the volume until the video actually starts. So I have to get through these commercials. Okay, so it's starting now. So let's start.
3.6, adding and subtracting.
So adding, subtracting polynomials. So I want to fast forward to, okay. So when you see stuff like this, adding polynomials, this is very easy when you see stuff like this, right? Collecting like terms, it's not hard. Okay, and so this will be an easy one to do, right? Not too difficult, right? I'll fast forward that. So let's collect like terms, and then you get your final answer, right? I think this gets difficult when there's fractions. These ones are easy. You got the 3 and the 7y, combine them, that's fine. Okay. The 2p and the 4p, combine them, that's fine. And then you have -7, -2, that's fine. Let's get into something that's complicated. Maybe you got multiple brackets. So this is easy, right? I don't think I should actually go through this one because there's more complicated ones, right? So basically what you're doing is combining like terms. You got different terms here, right? You got an x and a y and a coefficient. Combine them, okay? So let's see if there's any harder ones here. Oh, the one that's going to be harder if you have something like this where there's a minus in between. That's, so you're subtracting polynomials. That may be confusing, but it's not harder. All you're doing in this case here, you see the negative that's here, you can apply the negative to what's inside the bracket when you combine like terms. So this would become -7y, and this become, there's a negative, +4. Okay. So if you were to rewrite that, right? That negative makes everything inside opposite. Okay. And you just add the opposite. That's what you're basically saying. Add the opposite. Right? We must add the opposite. That's all I do. Okay. So that becomes simple. Add the opposite. So we're going to add -7y plus 4. Because the original is it's +7y and -4. So add the opposite. Okay. So that's not difficult. Let's fast forward to something else. Again, here you're just adding the opposite. Okay, so let's actually go back out and then do something a little bit more complex. So adding, subtracting are pretty easy. I'm going to say, let's look at the ones that are more complicated. Let's say multiplying polynomials. That's like doing distributive law and FOIL method. Okay. So again, there's going to be commercials. So I'm going to pause the volume for the commercials. We don't need to hear that. Oh, there's no commercials for this. Wow. Okay, that's pretty good. Okay, I'm just going to try to maximize the screen. Give me a sec, guys. Okay. Okay, there we go. So we're talking about multiplying polynomials. So let's get the volume going.
Working with transitioning between the different forms of quadratic.
So when we talk about multiplying polynomials, we're either going to do distributive method or doing the FOIL method. So let's fast forward to. Okay, so here it's simple, right? You're going to have 5 on the outside, multiply everything on the inside by 5. Okay, 3x, multiply everything in the inside by 3x. I believe you would have did this in grade 10, but this is just sort of a review. 2 on the outside, multiply everything by 2 on the inside. And I would have did this when we did the inverse function. So again, it's showing distributive, everything on the inside, multiplied by everything on the outside. Okay, you can see that. Okay, that's not very difficult. Distributive law would have been from grade 9, I believe. Okay. The next one would be when you have 2 brackets like this, 2 binomials multiplying each other. So you can use the FOIL method for that. Right? So the FOIL method would be the first times the outer times the inner times the last, right? So let's look at the FOIL method. It's going to show you. Again, FOIL method. So a little bit quicker. There you go. That's the first. And then the outer. And then the inner. Okay. So outer gives you 5x. Inner gives you 2x for this one. And then the last gives you 10. Okay, so it gives you 10, and as a result, you combine like terms. Okay. And when you combine like terms, you're going to left with 7x, x squared plus 7x. Okay. So this is simple, right? Don't need to go through much with this one because you guys would know how to do this from grade 10. I think, again, this is another easy one, another example. Okay, this is not going to be difficult. So is there any hard examples to look at? Let's look at example 3. What example 3 looks like. Again, it's not going to be difficult. That's going to be 3x times x, so 3x squared. So that's not a hard example. I think a hard example comes in when you have fractions. Here comes a commercial, sorry.
Going to Cancun.
Okay. Let's get the volume back.
Minus 35.
So I'm going to pause. I'm going to skip this video. So we know this is binomials. Let's go into something that may be a little bit more challenging. Let's look at, we know common factoring, we can do that. Let's look at the perfect square. Look at perfect square and then difference of squares.
Welcome back, grade 10 math. We're going to continue with chapter 5 today. Chapter 5 is about quadratic expression.
So again, you're saying grade 10 math because this is a review for grade 10, right? Looking at special products, we'll be looking at difference of squares or perfect square. Okay, so let's review that. Fast forward a little bit. So when you see something like this, you can write it out. This is a perfect square, but let me play out the video and let's see you can explain that. And then we'll break that down.
So, first off, we're going to learn about perfect square trinomials, okay? Before we learn the rule for that, let's just work on expanding these two.
Okay, so if you look at that perfect square, right, that's the same thing as writing it like this, okay? And it's really not much you have to, if I write it like this, it's the same thing writing like that, right? So if I write it like that, then I can still easily still do the first, outer, inner, and then last. I can still use the FOIL method to get the answer, right? Or I can do a shortcut because I know this is a perfect square, right? But if I were to do that, I'll get the final answer quickly. I mean, if I know the perfect square trick, then I can go quickly instead of doing this stuff where I can make a mistake in multiplying. I can go right straight to the answer, okay? And then same thing with this one over here. That's the same thing as writing x minus 6 bracket x minus 6 and doing the FOIL method, okay? That's what that is, okay? So, but let's see if he talks about the perfect square method right away. Okay, he's showing you how to write out, which I just showed you. So you can also do it in FOIL method. I just showed you that. Okay.
Want a smarter way to mop?
Sorry guys, I'm just gonna pause it through these commercials. We don't need to hear the sound in these commercials. Okay, back to the video.
And then we refer it back to the original.
Okay, so again, we're just fast forwarding. He's doing the FOIL method. Okay, so fast forward. We know how to do the FOIL method. Get into. Okay, so what he's now getting into is, if we look at that question now, I can go directly into my perfect square, okay? This is the rule that he's showing you on the screen here. I have a perfect square, which is the top one, or difference of square, which is the bottom one here. So when I look at that, I can go directly into my answer, right? So my answer, right, is gonna have x squared no matter what, right? But then my second term is gonna be based on this. 2 times my a, so a and b, right? So a and b is my x and my 3, okay? So my a and b together is 3x, right? Times 2 makes it 6x, right? So I know I'm going to have here 6x, and then I'm going to have here plus 9, okay? If you look at that, right, it tells you here a and b. So that means this is my a, my 3 is my b. This is my a, and this is my b. So if I'm going to do the bottom one, right away, I can just look at it and look at the difference of square and say, well, I'm going to always have x squared as my first term. My middle term is going to be minus, so I have here, if I look at this one here, x and 6, that's negative, that is negative, my bad, it's 6x, okay? I know my middle term is going to be negative, so it's 6x, and then it's going to be times 2. That's going to be 12x, okay? And then my last term is going to be 36. Okay. If you look at it, it works out. Okay. If I were to do the FOIL method, it'd work out. And I believe we can back up a little bit. You can see when he did the FOIL method, he got the same answer. Okay. Let's back up to the FOIL method. So x squared plus 6x plus 9, and another one was x squared minus 12x plus 36. There you go. See, we have the answers right there. Up there, x squared plus 6x plus 9. That's what we got there. And when I wrote it using the perfect square and the difference of square, and same thing there. Okay. Let's go back to real time. I think it was 22. Okay, so that's just a quick way of a way to get to the answer versus doing the FOIL method. Remember this rule and it can get your answer quicker, right? You also can look at this and go back and from here, look at this and say, oh, this looks like the perfect square. I can automatically get the factored form, which is this. And remember, you need this factored form in order to help you to get the vertex equation if it's a quadratic, okay? So let's play the video for a little bit. No, actually, we can't really play it. Don't have much time, but that's how you do that. You can watch the video on your own, but that's how you do that, though, okay? So I kind of went through the quick way of doing the perfect square. Yeah, let's clear that. Okay. He's just going to give you more examples, but we got the answer already. Okay. Cool.
B is 3.
Okay, so he's going through what I just went through. Okay, like he just said, A and B. There you go. Okay, so remember that. Is there any other examples? We're still going through that example. Here's another example, right? So if you make this example here, A and B, then you can figure out what would be. This would be minus, so it's a difference of square. Okay, you have to use that formula, and the formula. That's the formula for difference of square, right? So if that's the case, for this question here, I'll do this one example. If my A, so that means it's going to be x squared automatically. And then I have here 7x times 2. That's going to be 14x. And it's going to be plus 49. Okay. Over here, do this one quickly. You already have your x squared. And then you're going to have here, so 6x times 2 is 12x. And then 6 squared is 36. Okay, so that gives you, see, when you know the formula to do perfect square, it can go faster than doing the whole, FOIL method. Okay, that's the reason why you do that, to give you a shortcut. Okay, so let's fast forward. There you go, he gave you the answer. And the next one, same thing. And he gave you the same answer. Okay, so let's stop doing that and do just sort of the same thing. Let me clear the screen. Okay, so I went straight to perfect square. Difference of square, I actually touched on that. So the other ones, factoring, I think you guys can do that. But there's worksheets there. Okay, so is it worksheets? Give me a sec. The worksheets are not showing. Okay, give me a second, guys. It should be showing here. It's not showing here. Yeah, it's not showing. Give me a second. I want to make sure the worksheets you guys can see here. So I'm gonna have to stop sharing my screen and fix that. Hold on a sec. Give me a second. Should be showing. I want to make sure you guys There's a reason why I go in and look at it as a student. I want to make sure you guys see everything that you're supposed to see. And if you're missing something, then I can fix it right away. Okay, so it's probably when it starts. Let me fix that. Probably messed up the start time of that. Because it is August 1st. We're starting it for the time. Okay. Fix. Okay, I'll put it into the file. So now I'll get to the file open now. I probably screwed up all of them. Okay, it's showing now. So let me look at it as a student. And share my screen again with you guys. Okay, so I go under, you can click here to worksheets here, it'll take you there. If you're showing. Yeah, it takes you there, so you can see, okay. The worksheets are here. You can work on that. And let's double check the quiz. You can see the quiz. Because the quiz is what I mark. That counts for marks. And the quiz is there. Okay. Okay. Allow 2 attempts. Okay, guys, that is it for today. I'm going to stop recording. For those of you who missed any of the recording, I'm going to post it. You can watch it. Remember, there's also the YouTube lesson. You can go in there and look at the lesson. Because I skimmed through some things, right? So that way we, have time to get everything in within the hours. It's past an hour, but that's it. Okay. So again, the worksheet don't count for marks. You don't have to do every single question. The quiz is what marks, what counts. Okay. So let you guys go. Have a good rest of the day, and I'll see you guys tomorrow again at 9 a.m. Okay. Bye, guys.